All right, so moving on to lesson 3 in chapter 7, we're going to be looking at multivariable linear systems. So where we have more than 2 variables, could have 3 or 4, and some strategies on how to solve those. So let's jump right into it because there's a lot to get through. One thing that can be real easy to do is just use back substitution, but you're not always going to be able to do this. Right here, we already know one of the variables in our equation tells us that z equals 2. So we can just plug that in to find y in this second equation right here, because this equation only has 2 variables. So if we just plug in the variable we know, now we're only going to have 1. Then we'll be able to find use y and z once we find y to find x in the third equation. So we're just substituting back into the equations right above. So this first equation, y plus 4. But now we're going to plug in 2 for z equals 7. So that's going to be y plus 8 equals 7. So then y equals -1. Now we know y and we know z, so we can take those and plug them into the original equation, the top equation. X minus 2 times y is -1, plus 3 times z is 2. That should equal 9. So we get x minus 2 and minus 1 is plus 2, and then 3 times 2 is 6. And of course 2 plus 6 is 8. Then we subtract 8 and we get x equals 1. So now we got x, y, and z. And whenever we have multiple variables, we're going to write them as a almost like an ordered pair, but we call it an ordered triple because it's 3 numbers, not a pair of numbers. It's 3 numbers. So we'd write x first, of course, alphabetical order x, and then y is -1, and then z is 2. So there's our answer written as an ordered triple, x, y, and z. All right, you guys try the next one. We'll go. So right here, you can see your answer is 2, -2, 2. I feel pretty confident that most of you probably got that. If you did, let me know, and I'll explain it. But there's the work if you want to look through it and see how you got those answers. Let's go on and look at what to do whenever you don't have a situation where you can use back substitution. So right here, we don't have, z equals 5 or y equals 3. We don't know one of the variables. So how are we supposed to solve this system of linear equations? Well, we're going to use something called Gaussian elimination, which can actually be kind of fun. But what you want to do is you've got 3 steps that you can use to do this. Okay, so one step is you can switch any equations anytime you want. Okay, so if you just want to move one of the equations to the top and one to the bottom, you'll see why here in a second. Step 2 is you can multiply an equation by a constant. So kind of like we do when we do elimination. How you multiply an equation by a whole number, you can do that. And then the last step is kind of like elimination. You can add a multiple of one equation to another. And again, that's something like what we do when we do elimination. We multiply one of the equations by a number, and then we add it to the other equation to eliminate variables. And that's essentially what we're going to be doing whenever we do Gaussian elimination. We're just doing it with 3 variables. Okay, so the whole idea, the whole goal in this is to make this look like the last problems when we did back substitution. We want to eliminate things to where we get down to where one equation has x, y, and z. One equation, has y and z, and then the other equation just has one of the variables equals a number. Okay, so that's kind of our goal right here, is to do that elimination to where we can do back substitution to find our answers. All right, so here's how we're going to do that. So let's look at first right here. The idea is to eliminate some of the variables. So if we just take this first equation and add it to the second equation, we can see that that'll eliminate x in that second equation, right? So we're going to keep our first equation, x minus 2y plus 3z equals 9. But now we're going to add this first equation to the second. So when we do that, x and minus x cancel. Now the 3y minus 2y just becomes y. 3z and 4z make 3z and 1z make 4z, and then 9 and -2 make 7. Okay, so we change that second equation. Now our third equation is still the same, 2x minus 5y plus 5z equals 17. Okay, so that's one of the steps we can do, right? We can add a multiple of one equation to another. So that's what we did right there. We just added that first equation to the second. Now, if you need to, you can always add a multiple of it. So you can multiply it by number and then add it in order to cancel one of the variables out. All right, so now from here on out, we want to try to eliminate the x variable in this bottom equation and eliminate the y variable in the bottom equation so that it's just left with z equals a number. So we need to now eliminate 2x. So what we can do is take the first equation and multiply it all by -2, right, to cancel the +2, and then add those to the bottom equation. So imagine if I multiplied all of this by -2, and we're going to add that down here. So -2x and 2x will cancel. So I'm going to rewrite my first equation like it's written in the problem. I'm going to rewrite my second equation like it's written. But now my third equation, I'm going to add that top equation to it after I multiply it by -2. So -2 times x and 2x will cancel, which is the whole idea. -2 times 2y makes 4y. So then I add that down here to the -5y. 4y, -5y gives me -y. And then -2 times the 3z is -6z. I add that to 5z and I get -z. And then -2 times 9 is -18. And I add that to 17 and I get -1. Alright, so now I've eliminated the x in the second and third equation. Now the last thing I need to do is just eliminate the y in the third equation to get the z by itself. Well, it's already set up to where they'll cancel. I don't need to multiply by a certain number. I can go ahead and cancel them out right now. So if I just add the second equation to the third equation, it'll cancel. And over here is what I'll have. I'll have x minus 2y plus 3z equals 9. The second equation, I'll have y plus 4z equals 7. Now let's add this second equation right down to this third equation. Y and minus y cancel. 4z and minus z is 3z. And then 7 and minus 1 is 6. Alright, so then at that point we can solve it to get z. Well, no, one thing we need to do is multiply the equation right by a constant. So we need to multiply that bottom one by a third, right? So we'll take it and multiply everything by a third. That way we get just z. And it's the same idea as solving. You could just solve it for z. It's going to give you the same answer. But if we're following our steps, multiplying by a third is the next step you'd want to follow to make it z equals. And so then whenever you multiply by a third, you're going to get z equals 2. Now we can just do back substitution. We know z. We can plug it in to find y. So we got y plus 4 times 2 equals 7. That's y plus 8 equals 7. So y is going to equal -1. And then we plug in y and z into the original. Minus 2 times -1 plus 3 times 2 equals 9. So we get x plus 2 plus 6 equals 9. That's x plus 8 equals 9. So x is going to equal 1. So now we know x, we know y, and we know z. And our answer is 1, -1, 2. Alright. There's our ordered triple for our answer. Okay, so again, follow these original steps to do Gaussian elimination. The whole idea is to eliminate the x variable in 2 equations and eliminate the y variable in one of the equations so that you make it look like this part right here so that we can do back substitution. Okay, so out there, I didn't ever switch an equation. That's the one step I didn't really have to do. All I did was add a multiple of one equation to another, and last step I did is I multiplied the last equation by a constant value of a third to make it z equals 2. But you could tell right there, if you just divide by 3 on both sides, you're going to get z equals 2. All right, so you guys try this one, and I'll go over it and let you see if you did it right. So on this one's a little bit of a tricky part, but hopefully you remember what happens right here. So let's say I've already got the second and third equation don't have x's, so I'm obviously just going to take one of those and try to cancel out a y. So if I multiply the second equation by -3, that'll help cancel out the 3y in the bottom equation. So I'm going to multiply the second by -3 and then add it to the third. Well, when I add -3y to 3y, that cancels, but then the -3 times -z gives me positive 3z, right? And then when I add that to the -3z, that cancels also. And of course, -3 times 0 is 0, and 0 plus 0 will give me 0 also. So I end up getting 0 equals 0. Well, I talked to you the other day and told you that whenever you get a number equals itself, that means you have infinite solutions, right? So we're going to have infinitely many solutions. Now, one thing that they do in this book that sometimes you'll be required to do, but most of the time not, but I'll show you how to do anyways, is figure out what form those solutions have to be in. So right now we can see if we solve this second equation for y has to equal z, right? We just add z to the other side. So the y coordinate and the z coordinate are going to be the exact same value. Whatever y is, that's what z is going to be also in our second, third number in our ordered triple. So now we can use this as a substitution into the first equation to figure out what x has to be in the form of. So z minus 3z equals -1. So if we know that y and z are the same number, but how are those going to compare to the x coordinate? So we got x, 2 and minus 3, or 1z and minus 3z give you minus 2z equals -1. So let's solve it for x. Add the 2z, so x equals 2z minus 1. Okay, so now we can see that the first coordinate, and we'll use the letter a right here, because that way we're not comparing it to any of the other variables. So we'll say 2a minus 1 is going to be the x coordinate, right? We're just pretending z and y are a, so then that y coordinate is a and the z coordinate is a. But we can see that x is going to be whatever z or y is times 2 minus 1. So that's the form of our answer. Okay, we're going to have infinite solutions, and that's how we can find all our infinite solutions. Just plug some value in for a, any value for a, and that'll give you one of your possible solutions. All right, so the important part is to understand it's infinitely many, but being able to figure out the form that they're going to be in is something that you might need to be able to do also. Okay, so looking at something different a little bit now, it's called partial fractions. Now, essentially the goal of this is to take a polynomial fraction right here, okay, a rational expression with polynomials, and split it up into two different fractions, right? Kind of like if we had, the fraction 2 plus 3 over 5, we could split that up into 2/5 plus 3/5, right? Which is very simple when it's just numbers, but we're going to try to do that here with polynomials. So same idea, just splitting up and getting partial fractions. Okay, so the first thing you want to make sure of is that the degree in the numerator is less than the degree in the denominator. So right here, the degree in the numerator is 1 because it's x to the first, and the denominator is 2. So we can go ahead and do partial fractions and split it up. If you had a numerator that was a higher degree, you would need to divide using long division. I remember when we did long division with polynomials in order to write your partial fraction. So first you would have to do long division if the numerator was, say, x squared and the denominator was just x. All right, so first step after you check to make sure that the numerator is a lower degree is to factor the denominator. All right, so I'm going to have x plus 7, and we're going to factor the denominator. What multiplies to be 6 and subtracts to be 1. Well, that's 3 and 2. We're going to do x and 3, x and 2, and we're going to use a minus sign once. If we're going to use it once, we put on the bigger one. That means the denominator is going to be plus. All right, so now your next step is to write two different fractions with these as your denominator. So I'm going to split this up, and I'm going to have x minus 3 in one denominator, and I'm going to have another fraction, and I'm going to have x plus 2 in that denominator. And you don't need the parentheses, so you can erase those. All right, so we've got those, and we're going to put a capital A and a capital B up here. And now that's what our goal is. Our goal is to figure out what is A and what is B. All right, so imagine that you had these two fractions and you wanted to combine them together into the original. Well, we would have to make a common denominator, right? So we know that we would have to multiply the denominator over here, x minus 3 by x plus 2, and we'd also have to multiply the numerator by x plus 2, right? Same thing with the other fraction. We multiply the denominator by x minus 3, and we multiply the numerator by x minus 3. Okay, so that's the next thing we want to look at doing, is multiplying those numerators by the opposite denominator. Okay, so now we can see what's going to happen Okay, of course, if we had this down here, then the denominators would be the same and we could add them. So now we know the numerator, whatever this is up here in the numerator, this a times x plus 2 and b times x minus 3, it's going to have to equal this part over here, x plus 7. So we can say x plus 7 has to equal a times x plus 2 plus b times x minus 3. Right? Because those are my numerators. They got to equal each other. So now let's go ahead and distribute. A times x is ax, a times 2 is 2a. That looks like an s instead of an x. And then b times x and minus 3 times b. And that's going to equal x plus 7. Okay, so now what we want to do is group the terms that have the x's together. So I'm going to write ax plus the bx together, and then write the other two terms that don't have an x, 2a minus 3b together. All right, so here's what I've got. We've got the ax plus bx, so I'm going to factor out an x right there. And I do that, I'm left with a plus b times the x, right? If I go back and distribute that x, it'll give me the x plus bx plus 2a minus 3b. And that's going to equal x plus 7. Okay, so now from here, we can look and determine some equations, because right here the coefficient in front of x is a plus b. Over here the coefficient in front of x is 1. So look at that, we can determine that a plus b has to equal 1. And then the 7 is the number by itself, and over here the number by itself is 2a minus 3b. So we can say, all right, well 2a minus 3b, I'm losing in green, 2a minus 3b has to equal positive 7. And now we can find a and b by elimination, substitution, so whatever you want to use. So I'm going to do elimination. So I'm going to take a plus b and I'm going to multiply everything by negative 2. That way it'll cancel the a. So I get negative 2a minus 2b equals negative 2. Now I can combine, the a's will cancel. Negative 3b and negative 2b is negative 5b equals 7 minus 2 is 5. Then divide by negative 5, so b equals negative 1. And then I'll plug it back in to find a. So a plus negative 1 equals 1, right? Because b is negative 1. And then I add 1, so a has to equal 2. So now I've got a and I've got b. And now I can write the partial fraction. So my answer is actually going to end up being a is 2, so 2 over x minus 3. And then plus b is negative. So since b is negative 1, I'm going to put a minus right here instead of a plus, because I'll just put that negative out front of the fraction, and then over x plus 2. So there's the whole goal, is to take that fraction and split it up into partial fractions. If I go back and multiply the denominators to make them common denominator and add the numerators together, it's going to give me x plus 7 over x minus 3 times x plus 2, which of course is x squared minus x minus 6. All right, so again, a little bit of a complicated process. You want to first factor the denominator, right? And you're going to write your factors in different fractions, okay? And then from there, multiply the numerators, okay? Your a and b, or you might have a, b, and c if there's 3. Multiply those by the opposite denominators, and then you can set up your equation, a times x plus 2 times b times x minus 3 equals x plus 7. You distribute, right? Get the x's together, and then factor out the stuff that's with the x. Now you can see what that coefficient has to be. A plus b has to equal 1, because 1's the coefficient on x, and 2 minus 3b has to equal 7. So now you've got a little system of equations, and we can solve it with substitution elimination. All right, you guys try the one down here, and then we'll go over it. All right, so right here, the numerator, the degree is 1, and the denominator degree is 2, so we can go ahead and do partial fractions. We're going to factor the denominator, and you slide and divide, and so I did that over here on the right, and you get your factors x plus 1 and 2x minus 1. So I put those underneath the partial fractions, a over 2x minus 1 and b over x plus 1. It doesn't matter which one goes under a, which one goes under b. As long as you do the rest of your math right, it should be get the same answer. So from there, I'm going to take a and multiply it by the other denominator, x plus 1. Or really, it's the least common denominator is what we're doing. and then b times 2x minus 1. So that gives me a times x plus 1 plus b times 2x minus 1. And then I distribute, and I combine the x's together down here in the third step in red. So I got ax plus 2bx, so I got my x terms together, and then the other one's just a minus b. Then on that first two terms, we're going to factor out the x. So you got a plus 2b times x, and over here you got a minus b. Now looking at how that compares to the left side, the coefficient in front of x on the left is -1. So -1 has to equal a plus 2b, because that's the coefficient on the right in front of x. And a minus b has to equal the constant 5. So that's where I get my two equations written over here in blue and green. Now I just have to do elimination or substitution to solve for a or b. So what I'll do is I'll multiply this bottom equation by 2. All right, that'll make it 2a minus 2b equals 10. Now I'll combine that with the numerator, and the b's will cancel out. So I'll add the two now, the blue equation and the red one. 2a and a gives me 3a, and then 2b and minus 2b cancel, and then -1 and 10 gives me 9. So now I'll divide by 3, so a equals 3. Now let's find b. So plug 3 back in for a. 3 minus b equals 5. So I'll subtract 3, negative b equals 2, and then b must equal -2. So now I can write my partial fractions. I want that black right here. A is 3, so I'll have 3 over 2x minus 1. And then b is -2, so again I'll put a minus right here, and 2 up top, and on the bottom x plus 1. So there are my partial fractions that if I added together would give me 5 minus x over 2x squared plus x plus 1. Okay, so let's go on and look at one that might be a little bit more complicated. Okay, so whenever you factor the denominator, okay, you've got to be aware of using all the different powers of each denominator. So let me just show you what I mean, and it'll make more sense. So in this denominator, let's factor. We see that the numerator is a smaller degree than the denominator. It's x squared, the denominator is x cubed. So we can go ahead and split it up by factoring the denominator. So if I factor out an x, right, see, notice all three terms have x's in them. So I need to factor out an x. That's going to be x squared plus 2x plus 1. Now I can x box this part that's left in the parentheses. What multiplies to be 1 and adds up to be 2. Well, 1 and 1. So I got x, and then I've got x and 1, x and 1, and it's a plus sign on both. So they both get a plus. Okay, so I can rewrite that as x plus 1 squared. All right, so now what I was talking about is when you're writing your partial fractions right here, you need to be aware of using all the different powers of your factors. So right here, x plus 1 has a power of 2. All right? If you have a power of 2 on one of your factors, you also need to write one of your partial fractions as having that same factor, but as a power of 1, or all the powers less than it. So what I'm essentially saying is on my partial fractions, I'm going to write a over x, I'm going to write a b over x plus 1, and I'm going to write a c over x plus 1 squared. Okay, so this is really x plus 1 to the first that's underneath b. Okay, so since x plus 1 is a power of 2, I've got to write that as one of my fractions, but I also need to write a fraction with x plus 1 to the first. If I happen to get, x plus 1 cubed, then I would need a fraction with x plus 1 cubed. I would need a fraction, you don't need to write this part down, I'll need a fraction with x plus 1 squared. I would need a fraction with x plus 1 to the first. Okay, so I would need a different fraction for all the powers below the power that I have that's the highest, okay? So that's something that's different on this type of problem. We're still doing the same thing, but we're going to have 3 fractions right here as opposed to just 2, because we've got x plus 1 to the power of 2. All right, so same idea right here though, and in the numerator I've got 5x squared plus 20x plus 6, and the bottom x cubed plus 2x squared plus x. Okay, so now we've got to multiply, all right, the different fractions by the numerator, or the denominators that would be required to make the denominators the same. So my least common denominator right here is x times x plus 1 squared. So for this first partial fraction, what would have to multiply that denominator to make it this common denominator, x times x plus 1 squared? Well, it needs an x plus 1 squared. So I would have to multiply a then by x plus 1 squared. What's the b going to need in order to give it that common denominator of x times x plus 1 squared? Well, b is going to need an x, right? But it's also going to need another x plus 1 because it only has one x plus 1. So to make it x times x plus 1 squared, you're going to have to give that denominator an x, and you're going to have to give it another x plus 1, right? So I'm going to give the numerator b that also. Then with c, what's it going to need? Well, it's already got the x plus 1 squared, so it just needs an x. So I'd have cx. Okay, so that's got to equal the numerator, 5x squared plus 20x plus 6. All right, so now it's a lot of multiplying and foiling and all that kind of stuff. So I've got x plus 1 squared is going to be x squared plus 2x plus 1. Okay, that's just using FOIL, x plus 1 times itself. And then right here, I'm going to go and multiply b times x is bx squared, and b times x times 1 is bx. And I've got cx. Now it's going to multiply the a by everything. So ax squared plus 2ax plus 1. Now we've got plus bx squared plus bx plus cx. Okay, so long process, I know. So now we're going to take the squares, x squares, and put them together. We're going to take the x's and put them together, and take the constants and put them together. So ax squared, do I have another x squared? Yes, I have bx squared. Do I have any others? Nope. All right, so I'm going to go ahead and cross out just to make sure I don't lose anything. Now let's put the x's together. I've got 2ax. Do I have any other x's? Yes, I've got bx, and I've got a cx. All right, so I use all those, and then the constant that's left over is just 1. Oh no, sorry, that 1 should be times an a, so that's an a, not a 1. All right, so we have plus a out here, not plus 1. All right, so now we're going to do what we did a minute ago with factoring out the x's. We're just going to factor out the x squareds. So a plus b is multiplying x squared. And over here, we're going to factor out everything that's with the x's. So we got 2a plus, that's a b, not a c. Got ahead of myself. Plus b plus c is going to multiply by x. And then we've got just the a by itself. So you can see over here, now the equation was 5x squared plus 20x plus 6. So a plus b has to equal 5. And then 2a plus b plus c equals 20. And then 6 equals a. Get a equals 6. All right. Now we can do back substitution because look, we know a is 6. The other equation is a plus b, so we can solve for b real easy, and then we can use those to find c. So let's plug 6 back in for a. So we got 6 plus b equals 5. Subtract your 6, so b equals -1. Now let's plug -1 and 6 in for ab into our other equation. 2 times 6 plus b is -1 plus c equals 20. So that's 12 minus 1 is 11 plus c equals 20. Subtract 11, so c equals 9. Okay, so now we know b, we know a, and we know c. So we can write our partial fraction. So now we've got to go back and plug them into our partial fraction a over x, right? A is 6, so our answer is going to be 6 over x. And then plus b, b is -1, so -1 over x plus 1. And then c is 9, so plus 9 over x plus 1 squared. So there's our answer of partial fractions for that problem. All right, you guys give this last one a try, and we'll go over it and see how you did. Okay, so I'm going to go and I'm just going to walk you through most of it. So first off, you factor the denominator, x squared times x plus 1. So that's going to be our common denominator we've got to find. All right, notice that x has a power of 2. So we're going to have one of our partial fractions with an x squared in the denominator, and the other one with just an x in the denominator. Okay, because if it's got a power, higher than 1, you've got to put a fraction with that as a denominator, and you've got to put a fraction with every power below that as a denominator. So we've got a over x, b over the x squared, right? There's our x squared and our x, and then c over x plus 1, because x plus 1 this time just has a power of 1, so we don't have an x plus 1 squared. All right, so then at this point, we got to multiply the a, b, and c by whatever that fraction will need to make a common denominator. So for the fraction a over x, it's got an x, it still needs another x and an x plus 1. So we'll give a an x and an x plus 1. B has x squared, so it just needs the x plus 1. So b times x plus 1. C has the x plus 1, so it just needs the x squared. So I give c an x squared. All right, now we're going to, of course, say that's got to equal 4x squared plus 2x minus 1. Ax times x times 1. So ax squared plus ax times 1 is ax. And then b times x is bx, b times 1 is b. And we've got cx squared. So now we're going to group all the x squareds together. So we got ax squared and a cx squared this time, or the other x squareds. The x's go together, we got ax plus a bx, and then we've got just a b by itself. Alright, so factoring out the x squareds, we get a plus c times x squared, and then factoring out the x, we get a plus b times x, and then we just got the plus b. So now looking back at the left part of the equation, we can see that the coefficient in front of x squared is 4, so 4 has to equal a plus c. And then 2 is the coefficient in front of x, so 2 has to equal a plus b. And then the constant is negative 1, and that's just b. So b has to equal negative 1. So now since we know b, we can plug it back in and substitute it to find a and c. So we're going to say 2 equals a minus 1, because b is minus 1. Add 1, so a equals 3. And then plug in a into the other equation, we can find c. 4 equals a, which is 3, plus c. Subtract 3, so c is 1. So now we know c, we know a, and we know b. And we can write our partial fractions answer. A is 3 over x plus b, which is negative 1, so we'll put minus 1 over x squared. And then c is 1, so we'll put plus 1 over x plus 1. And there's our answer, our partial fractions. All right, so we're not going to do the word problem. We're going to skip it because the video's been long enough. Appreciate your all's attention. Let me know if you have any questions on this, and you can go ahead and practice some now.